Okay, today's lesson is section 8.3. It's on geometric sequences and series. Last class, you learned about arithmetic sequences and series. So that's what this warm-up is on. So please pause the video and try this warm-up. All right, so last class you learned about arithmetic, and this is the explicit formula that we used. So all we need is the first term and the common difference. So in this first one, I can see that my first term is 3. I can also see that from each term, I'm going up 0.5 to get to the next term, up 0.5. So that means that my d value is 0.5. So using this formula up here, that means my formula would be a sub n equals the first term of 3 plus the common difference of 0.5 times n minus 1. That's fine as an answer, but a lot of people like to make it look a little simpler here. So if we make it look simpler, it would be 0.5 n, and then that's going to be plus 2.5. Either one of those is fine. Most people are going to stick with this one, so that's my suggestion. All right, it also asked me to solve for the 16th term. So I'm going to use either one of these formulas. I'll use the simpler one to find the 16th term. So a sub 16 means the 16th term is 0.5 times the n value of 16. We want the 16th term plus 2.5. 0.5 times 16 is 8. 8 plus 2.5 is 10.5. So that means that my 16th term is 10.5. So this is your explicit formula. Technically, the one above it is fine too. And this is the 16th term. All right, if we look down at the next one, it's asking us to find the sum of the arithmetic series. So above, we're talking about sequences, just a pattern of numbers. Here, we're talking about finding the sum of a certain number of terms in an arithmetic series. So the things that we need for the sum, the formula is number of terms divided by 2 times the first term plus the last term. So those are the things we need. So looking at this problem, we have a few of them already. Number of terms, we don't know. First term, we do know, it's 85. And a sub m, which means the last term, we do know, it's 1. So because we don't know part of this, we need to do some work to solve for it. So to get the n value here, I'm going to first come up with my a sub n formula. So my a sub n formula is 85 minus 7 times n minus 1. I'm then going to plug in this for my a sub n, because that will tell me what term number I need to plug in order to get to that. So I'm going to put the 1 in for a sub n. I'm going to leave everything else the same, and now I'm just going to solve for n. So there's a couple ways you can do this. You can distribute the 7 if you want. I'm going to work to just get n alone here. So I'm going to first subtract the 85 over. So I have negative 84 equals negative 7 times n minus 1. Then I'm going to divide by the negative 7 and get 12. And then I'm going to add the 1 over to get 13. So these problems are a little bit difficult because we're missing something. Whenever you're missing something, you're going to go back to this formula. That's usually how you're going to figure out what you're missing. So we have what we're missing now. So we know that there are 13 terms in this series. So now I have everything I need, so I'm going to go ahead and solve it. The sum of these 13 terms is equal to 13 over 2 times the first term, which we said is 85, plus the last term, which we said is 1. And we do that math, and we get the sum of these 13 terms is 559. All right. So today's lesson is on geometric sequences and series. We're going to define what a geometric sequence is. We're going to write the rules, just like we did for arithmetic. And we're also going to find the sum of a finite geometric series. The next class we have, we'll also find the sum of infinite geometric series. Okay, so first what we have to do is we got to identify whether or not it's geometric or not. So we learned last class how to identify if it's arithmetic. That's if you have a common difference or the same number that you keep adding. For geometric, you're going to find out if you have a common ratio or the same number that you keep multiplying by. So just a really quick recap here. For arithmetic, this one, I can see that we are subtracting 3, and then we're subtracting 3 again, and that's going to hold true for this whole pattern. So my common difference is -3. That means it's arithmetic. Now, I always check for arithmetic first because it's the easiest one to check for. So on this next one, I'm going to check, okay, I added 3. Did I add 3 again? Nope, I added 5. So it is definitely not arithmetic. That's what I just learned there. The new thing I can check for now is geometric. Do I keep multiplying by the same thing? Well, to go from here to here, I multiplied by 4. To go from 4 to 9, I did not multiply by 4 again. So therefore, it is not geometric. So it is neither arithmetic or geometric. This one's actually perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So we'll just call this perfect squares. It's kind of a unique one. Not really a formula for that we're going to be using. Okay, but geometric is where we are at today. And I want to see what I keep multiplying by. Now, sometimes the multiplier is going to be real easy to see, like you keep multiplying by 2 or you keep multiplying by 3. Sometimes you're dividing, but I don't want you to think of it as dividing. I want you to think of it as what number are you multiplying to get from a certain term to the next term. And the easiest way to do that is find the ratio of any term divided by the previous term. So my R value is going to come from any term, so I'm going to take the second term. I'm going to divide it by the previous term. When I do that and simplify, I get 1/4. All I got to do is make sure that holds true. So now I'm going to check the third term. So if I take the third term of 16 and divide it by the previous term, which was the second term in 64, I still get 1/4. Now I'll take the fourth term, which happens to be 4, divided by the third term, which is 16. I still get 1/4. As long as that holds true and you have a common ratio, that means that it's geometric. All right, so this last one here, it looks like I multiplied by 2, so I'm going to go ahead and check that. Did I multiply by 2? All right, I did there. Did I do it again here? I did not. I multiplied by, what, like 5/3? That's what I think it is. Yeah, 5/3. So that is not a common ratio, so therefore I know that it's not geometric. I can then quickly check if it's arithmetic. So I added 6. Let's check if I did that again. I added 8. I did not. I'm also not noticing anything special. Like I don't see perfect squares here. I'm not seeing any sort of formula. So this is neither arithmetic or geometric, and it's also not anything I really want to talk about like the perfect squares was. So that's it. So you're just looking for a common ratio. Is there a number that we keep multiplying by to get the other numbers? So the only one that gave us that was this first one. We kept multiplying by 1/4. 256 times 1/4 gave me 64. 64 times 1/4 gave me 16. I don't want you to think about dividing. Think about what you are multiplying by, even though technically, yes, we are dividing by 4 each time. It doesn't help you with the formula, so think about it with what you're multiplying by. All right, so pause this video, give this slide a try, and check back and see if you agree with what I have. All right, so here we have an R value of 1/3. Since it held true throughout, that means it's geometric. Here we have an R value of 3, and then we have an R value of 4. It's not common, so therefore it's not geometric. So this one, I can see that we're not multiplying by the same thing. So I can see to go from 9 to 3 is multiplying by 1/3, and we obviously didn't do that for the 15 to 9. So I know it's not geometric. Now I'll check if it's arithmetic. It looks like it is. I'm going to subtract 6. I'm going to subtract 6. I'm going to subtract 6. Yeah, this one is arithmetic. The common difference is -6, and it's arithmetic. And this last one here, I have an R value of -2. I just keep multiplying by -2. That tells me it's geometric. All right, so this is your formula. I call it the explicit formula for a geometric sequence. It has some similarities to your arithmetic formula in that we're still looking for the first term here. My suggestion is you put this R value in its own parentheses. It doesn't usually matter, but sometimes it messes people up when they enter it in the calculator if it's not in parentheses. Your R value is your common ratio. So for instance, when I'm looking at example 1 here, I know by looking at the formula above that this is my first term and that this is my common ratio. So what that means is this pattern starts at 2. Oh, these are messed up. Hold on a sec, let me fix this. Alright, I'm going to cross this out. First term of 2 and a common ratio of 3. Alright, now our formula is correct. Sorry about that. Okay, so let's start that again. So in this formula, the first term is 2. So here's my a sub 1. And the common ratio is 3. So what that means is this pattern goes like this. First term is 2. My common ratio is the number I keep multiplying by, so I'm going to multiply by 3. Multiply by 3. And so on. So that's the pattern this one is talking about. All right, so pause the video and come up with the formula for each of these and also find the 15th term. All right, so the formula we're doing here is a sub n equals a sub 1 times r to the n minus 1. So all I really need is the first term and the r value. So I clearly have the first term right here. It's a 5. And I just got to look to see what my r value is. To go from term 1 to term 2, it looks like I multiply by 3. Let's make sure that I keep doing that. And I do. So that's my r value. R value is 3. So that means my formula is a sub n equals 5 times 3 to the n minus 1. Now it also asks me to find the 15th term. Well, once you have your formula, you just got to plug a 15 in. So a sub 15 equals 5 times 3 to the 15 minus 1. Now, of course, I forgot to do this ahead of time, so let's see what we get here. Probably a really big number. It is a huge number. All right, so we have... Wow, 23,914,845 is what I got there. Hopefully that's what you got. All right, let's do the same thing for the next one. So my first term, again, is this one, so 88. And my common ratio looks like I keep multiplying by negative 1/2. So that means my formula would be a sub n equals 88 times negative 1/2 raised to the n minus 1. And again, we need to figure out what the 15th term is. So this is actually going to end up being a pretty small number. But again, I forgot to do this ahead of time, so bear with me while I plug it into my calculator here. We're plugging in a 15 up here. So we have 88 times negative 1/2 raised to the 15 minus 1. Oh boy, really small decimal, which does convert to a fraction, so I'm going to do that. Our 15th term is 11 over 2048, which is about 0.0054. All right, there's my 15th term. Okay, for example 2 here, it says that one term of a geometric sequence is a sub 4 equals 12, and the common ratio is 2. So this is important to me. When I'm thinking about my formula, though, I know that I still need the first term, which does not look like I have here. I'm still going to use this formula to get it though. This 4 is actually my n value, and this 12 is my a sub n value. So I can use those because if I plug them in for n and a sub n, and I plug in the r that they gave me, the only variable I'm missing is a sub 1, so I'll be able to solve for it. So I'm going to do that right now. I'm going to say that 12 is equal to a first term that I don't know times an r value of 2 that I do know, raised to the n minus 1, but I know that my n value is 4. So that's 4 minus 1. So now I'm going to solve for a sub 1. 12 equals a sub 1 times, this is 2 to the third, so that's 8. I'm going to divide both sides by 8. I'm going to get 1.5 is my a sub 1. So now I have my first term and my r value, so I have the whole formula. A sub n equals 1.5 times r, which is 2, raised to the n minus 1. All right, so there's my rule. It says to write the first 6 terms. You have a couple ways to do this. Every year I have students that do it in my opinion, the longer way, which is they plug in, because now that you have this formula, you can just plug in a 1 and see what you get. Plug in a 2 and see what you get. You could do that for all 6. What's easier is you know that 1.5 is your first term, and you know that 2 represents your multiplier. So you can just keep multiplying by 2 to get the next term. So we have 3. Multiply that by 2, we get 6. Multiply that by 2, we get 12, 24, 48. There's your first 6 terms. I'm okay with you doing it either way. I think if you plug in 1, 2, 3 individually, it's just going to take a long time. All right, this is probably the hardest example of the day. It's not too bad, but we are going to be using a system of equations. You remember them, we did a couple of them this year, and also from Algebra 1, like you had a system of linear equations. You could solve it by elimination or substitution. So we're going to do that here. We're going to use substitution, though. So they gave me 2 pieces of information, and I'm going to use both of them with this formula. So this 2 is my n value, and this 12 is my a sub n value. So that means with this information, I have 12 equals a first term that I don't know, an r value that I don't know, an n value of 2 minus 1. I also have the information from this, which is the n value of 5 and the a sub n value of negative 768. So if I write that out, I have negative 768 equals a sub 1 I don't know, r value I don't know, n value in this case of 5, and then minus 1. So right now we have 2 equations, so we have a system of equations, and there's 2 variables that we don't know. So in order to solve that, we are going to substitute. So I'm looking at both of these, and the easiest variable it looks like to get alone is going to be a sub 1. You can get it alone in either one of the equations. I think it's going to be easier to get it alone where the r value has a smaller exponent, so that would be in this first equation here. So this is 12 equals a sub 1 times r to the 2 minus 1. That's just times r. So to get a sub 1 alone, I would have 12 over r. Just like in Algebra 1, once you get one variable alone, you take it and you substitute it into the other equations. So this value is my a sub 1 value. So I'm going to write it as my a sub 1 value. So we have 12 over r. That's my a sub 1 value. And I'm plugging it into this original equation. 5 minus 1 is just 4, so I'm going to put r to the 4th here. So now I go to simplify all this. I get negative 768 equals 12r cubed. I'm going to divide both sides by 12. I'm going to get negative 64 equals r cubed. I'm going to take the cube root, and I'm going to get r equals negative 4. So in my equation up here, I have the r value. I still need the a sub 1. Now we did get a sub 1 alone over here. So I should be able to just solve for it now. I'm going to take this negative 4 and plug it in for r. a sub 1 equals 12 over negative 4. That means that negative 3 is my a sub 1. So now I have both parts of my formula, and all they wanted me to do was write the rule. So here's the rule. Negative 3, which is a sub 1, times our r value of negative 4 to the n minus 1. You could always check if your rule works. I'll check it with the first one here. If I were to take a 2 and plug it in for n, do I get a 12? So a sub 2 is negative 3 times negative 4 to the 2 minus 1. A sub 2 equals negative 4 to the 2 minus 1. That's negative 4 to the 1. That's negative 4. Negative 4 times 3 is positive 12. So it looks like it worked. You didn't have to do this part, but you could just to check your work. All right, here is your answer for this problem. So that's pretty much as hard as they get. When you're given two separate data points, you're going to do a system of equations to solve it. All right, so pause the video, try these, check back with my work, see if you agree. So this is my a sub n, this is my n. So I have 96 equals a sub 1 times the r value they gave me of negative 2 raised to the n value of 6 minus 1. So I should be able to find a sub 1 pretty quick here. So that's 96 equals a sub 1 times negative 2 to the 5th is negative 32. Which means that my a sub 1 is negative 3. And I already had the r value, so my answer here is a sub n equals the first term of negative 3 times the r value of negative 2 raised to the n minus 1. All right, this one is the one like the previous example, where you're going to have two different equations and you're going to have to use a system of equations. So this represents this equation, 12 equals the first term, which I don't know, the r value, which I don't know, raised to the 2 minus 1. That's my n value there. This equation is 3 equals the first term that I don't know, r value that I don't know, n value of 4. You can choose either one to get alone. I usually choose the one that has the lower exponent on the r, so I'm going to choose the red equation over here, and I'm going to get a sub 1 alone. So we have 12 equals a sub 1 times r to the 1. This is very similar to the last problem. I divide both sides by r, and I get a sub 1 is equal to 12 over r. It won't always be that. It's just coincidence that the first two we did were 12 over r. So now you're going to take that and plug it in here. So we have 12 over r. And we're plugging it into our equation there. So we still have the 3. And then we still have r cubed here. So when I simplify that, I get 3 equals 12r squared. Divide both sides by 12, I get 1/4 equals r squared. And then I take the square root of that, and I get 1/2 is my r value. I still need my a sub 1, but I have it alone over here, so I'm going to put that 1/2 on the bottom here. When I put that 1/2 on the bottom, I get 12 divided by 1/2, which is 24. So 12 over 0.5 is my a sub 1. 24 is my a sub 1. So my final answer here is going to be a sub n equals the first term of 24 times the r value of 1/2 raised to the n minus 1. All right, and the last thing you have to learn here is how to find the sum of a finite geometric series. So you learn the formula for arithmetic, which was s sub n equals n over 2 times the first term plus the last term. So this one is different, but it's just a formula that we're going to follow. So it is the sum of n terms is equal to the first term times 1 minus the common ratio raised to the n value over 1 minus the common ratio. Now, those of you that have struggled all year with entering large equations into your calculator, not knowing where parentheses should go, I'm going to suggest that you put a parentheses just around the r here. You don't have to, but especially if the r value is negative or a fraction, it will help you to get the right answer. You might even need to, especially on older calculators, you might even need to put a parenthesis here. Again, it's not necessary either of those, but it might help some of you. So you need the first term you need the common ratio, you need it twice, and you need the number of terms in order to solve for a sum. So let's do that. All right, so we haven't touched on this knowledge you learned from last class, but we learned about summation notation or sigma notation. So if it's asking me to find the sum, I know it wants me to use the new formula that I just learned. So the sum of n terms equal to the first term times 1 minus the r value raised to the n value over 1 minus the r. So what I like to do with problems like this is I like to list all the things I need. So in order to find the sum, I'm going to need the first term, I'm going to need the common ratio, and I'm going to need the number of terms. I'm going to fill in anything that I already know, and if I don't know something, then I'll go back to my explicit formula to figure it out. So my first term, looking at this formula, well, this is your explicit formula for geometric, which means that this is your first term. So my first term is 4. And using that same logic, we know that your r value is 3. And using your knowledge from last lesson on summation notation, this is telling me start with term number 1 and go up to term number 10. So that means a total of 10 terms. I have everything I need. I just got to plug it in and put that in carefully into my calculator. So I'm going to say the sum of these 10 terms is equal to my first term times 1 minus my r value of 3 raised to the n value of 10 all over 1 minus 3. Now just be careful with the way you enter your calculator, but I do want you to try it. Don't just wait for me to put the answer up here. Make sure you get this same answer. So when I enter that, I got 118,096. So that is the sum. All right, so I want you to try that now. So pause the video here, try it, and then I'll put my answer up. All right, so the things I need for a sum are the first term, the r value, and the number of terms. So looking at this, I can see my first term is negative 16. I can see my r value is 0.5. And I can see, because we're going from term number 1 to term number 7, that there are 7 total terms here. I'm just going to plug it into my formula. The sum of 7 terms is equal to the first term times 1 minus the r value of 0.5 raised to the n value of 7, whole thing over 1 minus the r value of 0.5. Be careful when you enter in your calculator. When you do that, you should get negative 31.75. All right, that is it for this lesson. Here is your homework. Complete that and submit it into the Dropbox.